Definite integration. Copy the lesson objective down. Once you've done that, hit play, and we're going to talk about definite integration. Right, so far when we've been integrating unbounded, without limits, otherwise known as indefinite integration. What we can do now is we can introduce limits and integrate between these two limits. This is known as definite integration. So if we have a look at an example, we can see how this works. So here we've got to integrate 3x squared with respect to x. So our example, so let's call it such. And we've got to integrate 3x squared with respect to x from 1 to 2. So let's do that. 1 to 2, 3x squared with respect to x. So what we do is we integrate the 3x squared, add 1, becomes 3, divide by 3, gives us x cubed. And we use what are known as squared brackets. So we use the square brackets from 1 to 2. And what we do then is we substitute for 2 and 1. So we change x to 2, substitute x to 2, cubed, minus 1 cubed. So 2 and 1 take the value of x. That's going to be 8 minus 1, which is 7. Okay, you might be asking, where's the constant term? Well, we don't need one, because if we had a plus c here, we'd have a plus c here and here, they'd cancel each other out. So we no longer need to have a constant. Whenever we have definite integration, we don't use the constant. Okay, so hit pause, copy the example down. Once you've done that, hit play, and we'll look at another. Okay, so in this example, we've got to integrate x to the power of 1 over 3 minus 1 all squared with respect to x from 0 to 1. Okay, those are nice limits. Hopefully they'll work out well for us. So we want to integrate x to the power of 1 over 3 minus 1 squared from 0 to 1 with respect to x. So first things first, we've got to expand that out to be able to integrate it. So it's from 0 to 1. If we expand that out, it's x to the power of 1 over 3 minus 1 times itself. That's going to give us x to the power of 2 over 3 minus 2 x to the power of a third plus 1 with respect to x. So that's expanded. You might want to separate them out if you want to check x to the power of 1 over 3 minus 1 times x to the power of 1 over 3 minus 1. Okay, right, now we can integrate term by term. So we bring our square brackets in and we add 1 to the power, so that's going to be 5 over 3. So x to the power of 5 over 3 divided by 5 over 3 minus 2x, add 1 to the power, so it becomes 4 over 3 divided by 4 over 3 plus x, and that goes from 0 to 1. Okay, let's simplify. So we get the reciprocal of 5 over 3, 3 over 5, x to the power of 5 over 3 minus 2 over 4, or 1 over 2, and the 3 goes on top, so that's going to be 3 over 2, x to the power of 4 over 3 plus x from 0 to 1. Now we can introduce 0 and 1, we can sub for 0 and 1. So we have, I'm just going to shift my equal sign along here because we're going to have two quite long terms. So that's going to be 3 over 5 times 1 cubed, sorry, 1 to the power of 5 over 3 minus 3 over 2, 1 to the power of 4 over 3 plus 1, all minus, so 3 over 5 times 0 to the power of 5 over 3, but it doesn't matter what power because it's multiplied by 0, minus 3 over 2 times 0 plus 0. I tell you what, I'll put the powers in just to be complete. Right, so that means we've got 3 over 5 minus 3 over 2 plus 1 minus 0. Every single term is 0 there, which is, common denominator is going to be 10. 6 out of 10 minus 15 out of 10 plus 10 out of 10, which is equal to 16 minus 15, 1 out of 10. Okay, so that's your definite integration. Hit pause, copy the example down. Once you've done that, hit play and we'll look at another. Right, so this example, given that p is a constant and the integral from 1 to 5 of 2px plus 7 with respect to x is equal to 4p squared, show that there are two possible values for p and find out what they are. Okay, so in the first instance, what we need to do is integrate this function. Then we're going to equate it to 4p squared and solve for p. So let's do that. So if we integrate from 1 to 5, 2px plus 7 with respect to x, we get in square brackets, we're going to treat the p as a constant term. It is a constant. So we raise x to the power of 1 to the power of 2, divide by 2, so we end up with px squared plus 7x from 1 to 5. So we now need to sub for 5 and 1. So we've got p times 5 squared minus, plus 7 times 5 in square brackets minus p times 1 squared plus 7 times 1. Work that out, we've got 25p plus 35 minus p minus 7. 25 minus p gives us 24, and 35 minus 7 gives us, or 24p even, gives us 35 minus 7 gives us 28. Okay, so that's our integral part. Now we've got to equate that to 4p squared. So I'm just going to change color and work on the second half of the screen. Therefore, 24p plus 28 is equal to 4p squared. So I'm going to move all the terms to the right hand side. 0 is equal to 4p squared minus 24p minus 28. Okay, I'm just going to rewrite that. It's neater if I write it as 4p squared minus 24p minus 28 is equal to 0. I can see 4 goes into all three terms, so I'm going to divide by 4, leaving me with p squared minus 6p minus 7 equals 0. So if I factorize that, I'm going to have two values for p, which is what I need. So I've got p and minus 7. It's only got two factors, 1 and 7. One's got to be negative. Sorry, one of the factors has got to be negative. It's going to be that one in this case, because it's minus 6p. So p minus 7 and p plus 1 equals 0. So either p minus 7 equals 0 or p plus 1 equals 0, which implies that p is equal to 7 or minus 1. Okay, so those are our two possible values. Hit pause copy the example down. Once you've done that, hit play, and I've got some questions for you to attempt. Right, so questions for you to attempt. It's up to you with this one. I don't think you need to do all the questions because you're starting to have enough practice at integrating now. Maybe working through the left hand side, or A and C of each question up to number 3, and then work your way through. Right, good luck.